Alright, so up to this point we've looked at inverse functions and we've looked at mappings where we had 14, negative 6, and that gave us an ordered pair. So we could talk about ordered pairs and say that we had 14 comma negative 6, and we could call that f of x. And then we had f inverse of x, and to find that inverse we just switched the x and the y. So that was when we had a mapping. So we could take a mapping, or we could take a set of points, ordered points, and we could find the inverse of those ordered points. Then we took a look at graphs, and we said that if I have this particular graph right here, I can find an inverse function by looking at the reflection over the line y equals x. So I can come down here and my line's perfect. That'll work. Okay, and that line right there is y equals x. And we did this by taking data points. We took points off of our line. So we had maybe took this point and found its cohort over on the other side. And maybe we took this point and found its cohort. And we found those points by switching the x and y's. And then we were able to draw the approximate shape by connecting those points. So we looked at finding inverses by ordered pairs, finding inverses on a graph, and now the last objective is to be able to find, if I give you two functions, for you to be able to tell me if the two functions are inverses. So that's our objective for today. So let's take a look at that. Alright, so here we go. Using composition of functions to determine if two functions are inverses of each other. So here's what I want to recall before we get started, and that is that this is called function notation, f of x. And so with function notation, basically if I said find f of 2, that means everywhere that there's an x, I would put a 2. So given this function, f of x equals 3x minus 4, f of 2 would be 3 times 2 minus 4. So that would be 6 minus 4. So f of 2 would be equal to, that's a coincidental, that would be equal to 2. So this is a review of function notation, because what happens with a composition function is that when we're given two functions, f and g, then we have basically a notation that says f composed of g. Just like this is f composed of 2. So f composed of g will be written like so. And that basically means we're going to take the g of x function and we're going to put it inside the f of x. So everywhere there's an x, we're going to put g of x. And it goes the other way also. If I did g composed of f, that means that everywhere that there was inside the function g, everywhere there's an x, I would put f of x. So let's go take a look at this and see what it looks like. So you should go open your unit book to page 14 and 15, and you'll see these examples on the bottom of page 14, and they roll over to page 15. What I'd like you to do is I'd like you to use these examples to help you in your notes. So please make sure that you take the time to copy these down, work them through, do whatever you need. Alright, so the first one, here we go. We're going to basically start off and we're going to do f composed of g. And we'll talk about the consequences, or not consequences, but what occurs. Alright, so we have our f composed of g. Let's make that a little bit bigger. And so we're going to take f of x and we're going to plug g of x inside of it. So that means we're going to take f of the square root of x plus 5 over 3. And that's going to be equal to 3 x plus 5 over 3 squared minus 5. So now, what I want you to take a look at here and see is that this is where x used to be. So right there we had 3 times x squared. So now I have 3 times, here is my new x. My new x though is actually g of x. So I've taken g of x and I've plugged it inside my f of x, and now I'm ready to start solving. Well, now when we think about this, we have to go back to all of our rules we learned in our mathematic career. And that means that I have a square root. Well, I have a square root squared. Well, the inverse operation of taking a square root is to square something. So those two things cancel each other off. So essentially, I'm left with 3x plus 5 over 3 minus 5. So the square and the square root cancel each other off. Okay, I keep on moving myself along. And so now I come along and I have to distribute. Well, the beautiful thing is right now is that this 3 right here is in the numerator and this 3 right here is in the denominator. So those 3's cancel. I'm left with x plus 5 minus 5. Now you'll notice on this step I dropped my parentheses. That's because I'd completed everything I could inside my parentheses, so I was done. Last step, I simplify, and I find out that 5 minus 5 is 0, so I get x. So at this point, I have f composed of g of x is equal to x. Interesting. So now let's take a look at what happens if I do the other way around, if I do g composed of f. So let's give me 1 second to set up. I'm going to hit pause for just a moment. Okay, I'm back. I went ahead and set that up so it kind of save a little bit of time. So now I'm going to do g composed of f. So that means I'm going to take f of x and I'm going to stick that inside of g. So everywhere inside of g that there was an x, I'm going to put my function f of x. So if you look closely at this, what you'll see is that here's x. And that means I'm going to take this guy right here, excuse me, I'm going to take this guy right here, and I'm going to stick him in there for x. So if you come down here and look, I tried to color code it so you can see that was my x. So I had the square root of x plus 5, and that is now my x. Okay, so now I start simplifying. So this goes back to, you know, my order of operations and everything. So inside this guy right here, I end up getting, well, take a look on the top. Remember, take care of your numerator, take care of your denominator, and then work yourself out. So negative 5 and positive 5, or minus 5 and plus 5, simplify to just 3x squared. Okay, so I made that line a little bit long, so I'm going to shorten that up a little bit. Okay, I go down. Now I look at my numerator and denominator. I've simplified everything in my numerator. My denominator has nothing to do. But now I have a 3 on top and a 3 on the bottom. Those 3's cancel. And so I'm left with the square root of x squared. Well, square and square root are inverse operations, so I'm left with just plain old x. So my final solution here is g composed of f of x is equal to x. So what we just saw here is that we saw a verification that f of x, this given function right here, and this g of x right here are inverse functions of each other. We determined that by using composition functions. We did f composed of g and g composed of f. And yes, the answer to your question is you have to do it both ways. You don't just get to test it one way. In order for it to be an inverse function, we have to test both compositions both ways.